Hello everyone. Well, I'm not there today, obviously. Today's lesson is going to be over finding the greatest common factor and using the zero product property. So we're going to be taking a look at that today. This should be a quick and easy lesson for you. Make sure that you listen to it all the way through. There's going to be some things in here that you're going to need to know in order to do your homework. This information will not be on the quiz, but be reminded that you do have a quiz next class period. And so you want to make sure that you prepare for that. And we will do a little bit of review before the next class period. So you'll be able, or before the quiz for the next class period. So you'll be able to at least get that. And I will be there for that. So, all right, here we go. I can factor using greatest common factor using the GCF. That's a C. All right, when a factored form is when a polynomial is written as a product of two factors. The solutions are called, and there's three different things that they're called. They all mean the same thing. You may hear me say find the roots. You may hear me say find the zeros. And we talked about these already before when we were doing maximum and minimum. We were finding the zeros, or they're also called the x-intercepts. So those all mean the same thing. So I might say, all right, find the roots of this problem. Find the zeros of this problem. Find the x-intercepts of this problem. You're going to do the exact same thing for each one because they mean the same thing. All right, so looking at this standard form, x squared plus 2x. We know it's in standard form because the highest exponent is written first. If I want to factor that, I have to take the greatest common factor out of both of the terms. So if I have x squared and x, the greatest common factor that I could take out of both of those would only be 1x. I can only take one of those x's out because this one only has one to take. It does not have more than that to take. So you can't take more than what it has. So if I take an x out of both of those, I would write the factored form as your x goes on the outside. That's your greatest common factor. And what's left after you take the x out, so out of here, if I take x squared divided by x, I'm going to be left with just an x. Plus, if I take an x out, I'm going to be left with just 2. So what goes inside the parentheses, it's what's left of the factor after you've taken the greatest common factor out. All right. And then this one, it's just in standard form. We're going to learn how to factor these later on in the next couple of class periods. We're going to learn how to factor trinomials. So the next part is factoring polynomials using the greatest common factor. To solve a polynomial, you may need to factor it first. Look for the greatest common factor. Which is GCF, what we use for short, of all the terms. And underline that word all. That's the important thing, is we have to take the greatest common factor out of all the terms, not just one of the terms. The greatest common factor is the greatest common number that divides evenly into each. So let's take a look at some examples. We're going to identify the greatest common factor of the following terms. Now we're not looking at expressions yet or polynomials yet. We're just looking at some terms to see what we can figure out what the greatest common factor is. Sorry, you can hear my dog barking. All right. So I have 16, I have 8, I have 20, and I have 36. What number can be divided evenly out of all of those factors? Okay, so if you think about it, probably 4 might be the best factor. So greatest common factor would be 4. If I take a 4 out of 16, I'm going to be left with 4. If I take a 4 out of 8, I'm going to be left with 2. 20 divided by 4 is 5. 36 divided by 4 is 9. All right, so the greatest common factor would be 4 out of each of those. If I look at number 2, x squared, and x to the third, if I take a greatest common factor out of each of those, how many x's could I possibly take out of all of those? Well, this one has 1, this one has 2, and this one has 3. So the most that I could take out would be just one of those x's, because I can't take any more out of that first one. All right, number 4, 6x squared, 9x squared, 15x squared, x squared, or 30x squared. They all have x squared in common, but what number can we also take out with it? So the greatest common factor here would be, out of 6, 9, 15, and 30, 3 would be the greatest number that I could take out, and x squared. So the greatest common factor would be 3x squared. All right, so see if you can do number 5 on your own, see what you can come up with. I'll give you a minute or so to try that out. All right, if you're still working, you might want to just hit pause for a second until you're done so that you can see if the answer that you get is correct. All right, so for this one, the greatest number that we could take out would be a 5. And the greatest variable with the exponent that we could take out would be x squared. So the greatest common factor would be 5x squared. All right, hope you got that one correct. And then you can try 3 and 6 on your own, but that's the gist of it, to see where you're at. Let's see. All right, now we're going to find the greatest common factor of this polynomial. So we're given the polynomial, and we need to take the greatest common factor out like we did in the very beginning, and then we need to write the other factor. So first of all, what can I take out of both 9 and 12? Well, I can divide a 3 out of both of those. So my greatest common factor is 3. Now I'm going to divide each term by the greatest common factor and put it out front. This is the factored form. So if I want to write this in factored form, if I take a 3 out of both of those, I'm going to take my 3, I'm going to write it out front, and then what is left after I factor a 3 out? So 9 divided by 3 is 3. I still have my x, and then minus 12 divided by 3 is 4. So if I take a 3 out, I'm going to be left with 3x minus 4. So this is the greatest common factor, and this is the other factor. So there are 2 factors. One is your greatest common factor, the other one's just a factor that's left. All right, so we're going to practice doing that for each of the examples below. So we have 6 examples. We're going to work through a couple of those. For number 1, what can I take out of 8x plus 16? I can take an 8 out of both of those. So if I divide each of those by 8, I'm going to be left with x plus 2. If I multiply this back, just to check my work, 8 times x is going to give me 8x, plus 8 times 2 is 16. They match, so I know that my factors are correct, because when I multiply them back, I get the same answer. What you want to be careful and look for is when you have, like number 4, when I have extra variables, what happens if I don't take out enough? So my greatest common factor here of the numbers would be 7, because I have 21 and 14. So 14 can't go into 21, but 7 can go into both of those. And then what if I just put x instead of x squared? Because I know it should be 7x squared, but what if I accidentally just put x? When I find the other factor, I'm going to get a 3x here minus 2x to the third. Well, seeing that both of these still have x's tells me that I did not take enough x's out. So when we have the other factor, this factor right here cannot have all those extra variables that are exactly the same. They should not have that on both terms. Okay, one of the variables should go away, so it should cancel out. So that means I didn't take enough out. So I'm going to have to go back and fix it and take out as many as I need to for my x values. So I'm going to have 7x squared should be my greatest common factor, and that would leave me with 3 minus 2x squared. Now I don't have any I don't have an x here, which is good. I still have a couple x's here, but I don't have any inside the parentheses more than just one term. So that's my factored form. All right. Now if we look at number 5, we have a trinomial. So the trinomial, 8x plus 10x squared minus 4x to the fourth. When we are factoring those out, what's the greatest factor that I can take out? So I have 8, 10, and 4. And out of that, the greatest common factor would be a 2 and an x to the first power, because this one doesn't have any more than one x. So then what do I have left? I have 4 plus 5x minus 2x to the third. If I multiply it back, I can see that that it matches. All right. That is factoring out the greatest common factor and then writing the other factor with it. So this is what we just did, was the factored form. Now we are going to look at the zero product property. What this says is, if you have two factors multiplied to each other, a and b, equal to 0, if the two factors multiplied together equal 0, then either a equals 0 or b equals 0, or both. So what this is saying is, if both factors multiplied together equal 0, that means that each individual factor is also going to equal 0. So using the zero product property, we can say that if this is a and this is b, they're multiplied together, they equal 0, then I can take each individual factor and set them equal to 0. What this is doing for me is it's finding the roots that I need to solve the problem, or the zeros, or the x-intercepts. It's finding those values. So my first one, x equals 0, we know that I don't have to solve anything. But the second factor, I'm going to have to solve it for x. I need to find what x equals. So if I solve it for x, I get x equals -3. So my roots are 0 and -3. So there's your answer. Roots are 0 and -3. All right, if I have one like this, 4x and x minus 1. So the factors are set equal to 0, so I can set the individual factors equal to 0 and solve for my roots. So in this case, if I divide by 4, I get x equals 0. Add 1 to both sides to solve for x, I get x equals 1. So my roots, or my zeros, are 0 and 1. And there you have it. And again, these are all called zeros, roots, and x-intercepts are all meaning the same thing. So I might ask you find the zeros, I might ask you to find the roots, I might ask you to find the x-intercepts. Just know that they mean the same thing. All right, this one, it already has two factors. So they're both multiplied together equal to 0, so that means I can separate them and set them equal to 0. Subtract 5 from both sides, I get x equals -5. Add 3 to both sides, I get 2x equals 3. And then I still have to divide by 2. X equals 3 over 2. So my roots are -5 and 3 over 2. And then the last one, remember when we have x minus 7 quantity squared, this says that I need to write this thing 2 times. So when I do that, I get x minus 7 is equal to 0. Since they're both exactly the same, I don't need to write it equal to 0 twice. I'm just going to solve it one time, and I'm only going to have one root. So the root is 7. That R looks a little funky there. So the root is 7. There's only one root or one 0 or one x-intercept. All right, so we're going to do a little bit of practicing of that in the bottom. So solve by factoring out the greatest common factor. So we're going to put the two together now. We're going to take what we learned on the front side, how to factor out the greatest common factor, and we're going to apply it to the zero product property. So in order to solve for the zeros or the x-intercepts, you have to take the greatest common factor out. You have to get it in factored form, and then you can set them equal to 0. So if I look at the first one, make sure that the equation is set equal to 0 and in standard form. So that's 2 important things that we need to make sure that is happening first. Then we're going to factor out the greatest common factor. So I'm going to take out of 2x squared plus 8x, I'm going to take a 2x out. So that's my greatest common factor. And then I'm going to put what's left, which is x plus 4. So there's the factored out form. Then I have to set the quantity equal to 0. So this is equal to 0, so I'm going to set each quantity equal to 0. And then I'm going to solve, just like we did above. So this one, x equals 0 and x equals -4. So my roots are 0 and -4. Okay, so we're going to do that. We're going to practice that a little bit. On number 1, I can take an m out. I'm going to be left with m minus 5 equal to 0. So then we have m equals 0, m minus 5 equals 0, and then m equals 5. So my zeros, or roots, are 0 and 5. Okay? And then you can do that for all of the other ones. We're going to take a look at number 4. What's different about number 4 is that it's not set equal to 0. So we have to make it equal to 0 in order to do the zero product property and to find the roots. So what I need to do is I need to move this over here by adding 18n to both sides. That's going to give me 4n squared plus 18n equals, and this side is 0. Now I can use the zero product property by factoring out the greatest common factor. So out of 4 and 18, the greatest common factor would be 2n. Then I have 2n plus 9 is equal to 0. Now I can set each factor equal to 0. So n equals 0 here. Subtract 9. I get 2n equals -9. Divide by 2. So then n equals negative 9 over 2. So my roots are 0 and negative 9 over 2. All right, so I think that's pretty much it. That's how you do those. You can try to practice a couple other ones if you'd like, but you'll get plenty of practice in your homework. So there you have it. You are going to have a little bit of extra homework because I did give you the quiz review that is going to go with your assignment. So I want you to work on that quiz review and be prepared for the quiz on Thursday because I won't have a whole lot of time to go over it with you. So I want you to come prepared and ready to take that quiz. Okay? All right. Well, hopefully you guys have a great day and I will see you on Thursday.